Hello everyone, this is Hating Tian. This video we will learn chapter 2.1, basic set concepts. So first, let me introduce the definition of a set. A set is a collection of objects whose contents can be clearly determined. The objects in set are called elements or members of the sets. Actually, the sets, just like we order things in different categories. In mathematics, such collection we call the set. Just like if we say students, so all the students is in this set, is in this category. There are three kinds of way to represent the sets. The first way is word description. We can describe set W as the set of the day of the week. So this is the description method to describe a set. And another one is raster method. Raster method, we list all the elements in a pair of braces. So if the set, we call it W. W is use braces and list all the elements here. Maybe we have 1, 2, 3, 4, and 5. We have 5 elements and list all the elements of the set W. Here is an example. W is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. These are all the 7 days in a week. So this word description equals raster method W. Another example, write a word description of the set P. The set P is Washington, Adams, Jefferson, Madison, Monroe. When we use the word description, we can say the set P is the set of the first 5 presidents of the United States. Next example, set C is the set of US coins with a value of less than $1. Express the set using the raster method. We must list all the coins with a value value of less than $1. So C is use braces. We list penny, nickel, dime, quarter, $half. We list all the coins in the sets. Next one is set builder notation. This is the third way to express a set. In this part, the W is that set, and the equal sign we can say is that the set W is all the elements X, and this part we say such that X is the day of the week. We can also use this way to represent a set. Okay, here is 2 examples. First example, when we use the word description, B is a set of the elements of Beatles in 1963. We use raster method to say B is all the elements of we said the member of the Beatles. That's George Harrison, John Lennon, Paul McCartney, and Ringo Starr. Another way to represent the set B is the set B is all the elements X such that X was the member of the Beatles in 1963. Here is another example. The set S is a set of states whose name begin with letter A. And raster method. S is all the elements. S equals all the elements I talked about in the set S, which is Alabama, Alaska, Arizona, Arkansas. When we use the set builder notation, we say S is all the elements X such that X is the US state whose name begins with the letter A. Okay, let's continue to next example. This example express set A. Set A. This is the set builder notation. Set A is all the elements X such that X is a month that begins with the letter M. Using the raster method, we list all the months which begins with the letter M, which is March and May. We may have this kind of question in the assignment and the exam. Next part is define and recognize the empty set. What's the meaning of empty sets? That means there's no elements in the set. For example, this is a set contains all the elements X such that X is a number greater than 10 and less than 4. When I see these kind of descriptions, I'd like to use a number line to find. So this is a line, and this number is, here is 4, here is 10. This number is greater than 10, is here, and less than 4, here. This number need to satisfy these two parts. Must be here. At the same time, this number must be here because the word and means need to satisfy both conditions. So can we find any number in these two? Oh, at the same time in these two parts? No. If we have the and, that means must be in the intersection of these two parts. So there's no elements can satisfy both of this condition. That means this set is an empty set. The empty set, we also called it null set. It contains no elements. We use these two notation to represent empty set. The braces have nothing in it, or we use phi. Be careful here. The empty set is not represented by this. You will never see this, or you can't use it in your exam or your assignment. Okay, next example. Which one of the following is empty set? First one is not empty because it contains one element, which is 0. So this is not empty set. And the second one is not a set. Sets need to have braces. And also the 0 is one element. We can't say this is sets. Number C, this sets, let's see the condition. X is a number less than 4 or greater than 10. Or means I just need to satisfy either of these two conditions. Let's draw a number line and find 4 and 10. This number need to satisfy less than 4 or greater than 10. So just to satisfy one part should be okay. So I can find many numbers in these two parts because that means or. So this is not empty. I can choose any number in these two parts. So this is not empty sets. Next one, the condition is X is a square with exactly 3 sides. What's the meaning of square? That's like this. It must have 4 sides. So a square with 3 sides, that's triangle. I can't make a square with 3 sets. So this one is an empty set. I can use phi to say this is empty set, or I can or I can say this is empty sets. Let's move on to next one. Which one is empty sets? Let's see the condition. X is number less than 3 or greater than 5. Let's draw a number line. Here is my 3, here is 5. This number less than 3. Less than 3 or means just satisfy one condition should be okay. Greater than 5. So I can find many numbers. Next one, number B. The condition is less than 3 and greater than 5. That means I need to find the intersection of these two conditions. So it's still 3 and 5. So they don't have intersection, no overlap. That means that's empty sets, no elements. Number C, nothing. This is not a set. This is just a word or description. So I can't say this is a set. Next one, we mentioned about in maybe 10 minutes or 2 minutes ago. I forgot. So the empty set, we can only use phi or the braces without anything in it. We use these two to represent the empty set. We can't use this in our notation. So this question we choose B. Let's move on to part 3. Use a symbol, this and this. This one means an element of a set. For example, 5 is an element of set 1, 2, 3, 5. So 5 is an element of 1, 3, 5 because we have an element 5 in the sets. But this one, that means it's not an element of the sets. If my sets only have 1, 3, I erase these two. So if my sets only have these two elements, and 5 is not an element of this sets, I should say 5 is not an element. It is not an element of the sets 1, 3. So let's see the example. Determine whether each statement is true or false. Number 8, R is an element of A, B, C, D to Z. This is English alphabet. So there is an R here in the sets. So this is true because R is in the sets in the English alphabet, 26 letters. Number B, 7 is not in the sets. This is correct. You can't find 7 in the sets. Number C, the sets is an element of the sets AB. So we mentioned that before, this part must be an element like A or B or something. You can't have this. This means this part is a set. So this one is wrong because we can't have this and this together because this sign means an element, but the front part is a set. So we can't use the set A is an element of a set AB. Okay, let's move on to next question. Next example, true or false? 8 is in 1, 2, 3, 4 to 10. Yes, this is true. R is not an element of A, B, C, Z. This is true because you can't find Z in the sets. Next one, you see the braces and the element of sign. This sign set means you can't have these two parts. That means wrong. That's false. Let's move on to part 4. Apply set notation to sets of natural numbers. The sets of natural number is 1, 2, 3, 4 to the infinity. That means infinite many numbers. So this is natural number. So people will ask, well, how about 0? Is 0 natural number? No. 0 is not an element of a natural number. 0 is an element of a real or integer. So it's not belong to the natural number. Okay, next example. Express each of the following set using the raster method. Set A is a set of natural number less than 5. When I see this description, I'd like to draw number line. So when I see number line, I put 5 here. Natural number less than 5. Okay, and remember natural number including these numbers. So my raster notation should be 1, 2, 3, 4. That's it. Because less than 5 is not included. Next one, number B. Set B is a set of natural number greater than or equal to 25. So draw a number line and find my 25. Greater than or equal to, that means this point is included. This number is included. That means the set B equals 25, 26, 27, etc. Number C, E is all the elements X such that X is in natural number and X is even number of the natural number. That means E equals 2, 4, 6, etc. Yes, they need to satisfy both natural number and it's even. Okay, let's move on. The next example, set A is a set of natural number less than or equal to 3. So draw number line less than or equal to 3. 3 is included. And natural number, that means A equals 1, 2, 3. 1, 2, 3. Next one, set B is set of natural number greater than 14. So draw number line 14, greater than 14. 14 is not included. So B equals 15, 16, 17, etc. O, let's see the condition of O, the set O. It's natural number and X is odd. That means O is odd number 1, 3, 5, ... infinity many. And here are some review. It's very, I think it's not hard for you. So let's see some simples here. This is a simple and it will appear here in the notation. In the notation part, that means X is less than A. So in the set builder notation part, it need to satisfy X is in natural number in N, and at the same time, X is less than 4. So if you draw a number line, and first you remember N equals 1, 2, 3, ... So you need to satisfy this number X is in the natural number N, also is less than 4. So here is 4 is less than 4 and need to satisfy 1, 2, 3, 4 to the infinity. So the raster method is 1, 2, 3. I think this kind of question is shown in previous examples. And next one, the notation here is in this part is x is a natural number less than or equal to 4. Also, I draw a number line. This is a 4 less than or equal to 4. That means 4 is included because it has equal sign here. So it's included. The raster method is 1, 2, 3, 4. Next one, x satisfied these two conditions. Greater than 4 and in the natural number, draw a number line greater than 4. It's not included. Okay, should be started from 5, 6, 7, 8 to infinity. And next one is x need to satisfy the natural number n greater than or equal to 4. So this is 4, and 4 is included because it has equal sign. So it starts from 4 to the infinity. Next part is the same. X need to satisfy x is in n and x is greater than 4 and less than 8. So draw a number line. 4, 8, it's in between. And these two numbers are not included. So I can have 5, 6, 7. Next one, 4 and 8 are included. We have 4, 5, 6, 7, 8. Next one, so just to draw number line is 4 and 8. 4 is included, 8 is not. So the number between these, all the natural number between these is 4, 5, 6, 7. Next one, satisfy this and this. So 4, 8, and 8 is included, 4 is not. So from 5, 6, 7, 8. Okay, let's see some example. The first example, express each of the following set using the raster method. So draw a number line. That's x is natural number and x need to satisfy less than 100. This is 100 and less than 100 is from 1 to, you remember n equals 1, 2, 3, etc. So this one, the set should be 1, 2, 3 to 100. And the next question is, draw a number line is from 70 to 100. Be careful, 70 is included, 100 is not. You see, I have solid dots here, and 100 is not included. I have a hollow dots here. Okay, so this set need to be 70, 71 to 99. Okay, next one is number 5. Determine a set's cardinal number. A number of elements in the set is called cardinal number or cardinality. For example, if my set is A equals 1, 2, 3. Oh, why my screen is not good looking? Okay, 3. There are 3 elements. That means I have the cardinal number of A, n of A equals 3. For another example, the set AEIOU contains 5 elements. So the cardinal number is 5. Normally, we will say, if this set is still A, we say n of A equals 5. That means the cardinal number is 5. The cardinal number of set A represented by n of A. Oh, it shows you here. Okay. Repeating elements. So this part is important because it's tricky when you're doing your assignment. in a set neither adds new elements to the elements or changes its cardinal. For example, the set A contains 3, 5, 7, and the set B contains 3, 5, 5, 7, 7, 7. So you see in the set B, there are 2 5s and 3 7s. So, but the cardinal number for the B is still 3, even they have the repeated element. We just cross out the repeated element. And to see the distinct element, we have 3, 5, 7. That means the repeated element will not affect the cardinal number. We just cross them out and to see what's the cardinal number of this set. So the n of A is 3, n of B is 3, 2. So move on to next question. Find the cardinal number of each of following sets. N of A equals, just count, 1, 2, 3, 4, equals 4. There are 4 elements. N of B, only 1 element, so it's 1. N of C, you just count it, or you can use your fingers to count how many elements. There are 11 elements in the sets. And how about the empty sets? The cardinal number is 0 because there's no element. We're looking for elements, but this is empty sets. No elements means the cardinal number is 0. Okay, next part is recognize equivalent sets. The definition is A is equivalent to B, means set A and set B contain the same number of elements. That means n of A equal n of B. If n of A equals n of B, that means A is equivalent to set B. For example, A equals 3, 5, 7. Oh, this is a previous example. And B equals 3, 5, 5, 7, 7, 7. So I prefer to cross out the repeated elements. So n of A is 3, n of B is 3. They are equal, they have equal cardinality. So set A is equivalent to set B. Next part, 7. Distinguish between finite and infinite sets. So normally you will understand what's the meaning of finite and infinite. Finite means you can the number or the elements you can count. Infinite means so they are countless, like so many numbers or so many elements. You can't count them. They are infinite many. That's the meaning of finite and infinite. Let's see the finite and the infinite sets. Set A is finite sets if n of A equals 0 or n of A is a natural number. That means the n of A could be 0 or 1, 2, 3, any natural number. A set whose cardinality is not 0 or a natural number is not 0 or natural number is called infinite set. Let's decide which one is infinite set, which one is finite set. The set A, let's see the condition, is an x is a natural number and x is less than or equal to 100. So use a number line, 100 and less than or equal to 100 is included. So the set A is 1, 2, 3 to 100. The cardinal number is 100. You can count, there can be counted. So this is finite. Next one, this set, I need to find a number line to see. what the set is. 100 is included and is greater than or equal to 100. That means to the infinity. I use this sign to represent infinity. So can you count how many elements in the sets? No, you can't. So I can't say how many a natural number or zero here. So I should say this is infinite many. So this is infinite sets. Next part is recognize equal sets. We learn equivalent sets. Right now we learn equal sets. If the set A equal to set B, means that set A and set B contain exactly the same elements. Be careful, regardless of order or possible repetition of elements. We use A equals B to represent these two sets are equal. So let's see the example. For example, if A is W, X, Y, Z, and B is Z, Y, W, X. Let's go back to see the definition, regardless the order. So this is different order, but they contain the same elements, which is W, X, Y, Z. W, X, Y, Z. They have exactly the same elements, even they have different order. Still, A equals B. So you see this image shows they just change the order, but they have the same elements. Here is the sentence is important. If two sets are equal, then they must be equivalent. If two sets are equivalent, the n of A equals n of B. If two sets are equal, they must have the same cardinal number. That means if two sets are equal, then must be equivalent. Let's see an example. Determine the whether each statement is true or false. So this A, the set is 4, 8, 9, and another set is 8, 9, 4. They just change the order. They are equal. This is true. Next one, 1, 3, 5. And another set is 0, 1, 3, 5. And this one has cardinal number is 4, and this one is 3. They are not equivalent and not equal. So this one is false. Next one, true or false. This set is 4, 5 equals 5, 4, and there is a 5 here. We can't say that there is we can't put a 5 in a set. So when you see this kind of notation, that's wrong notation. This is false. Even you think 5 and 4, 5 and 4, they're matches, but there's a weird things here. This is a wrong expression. We put false here. Next example, A equals 10, 11, 12. B equals 12, 12, 11, 10, 10, 10, 10, 10, 10. So I prefer to cross out the repeated elements. So what's left? 12, 11, 10. And in A is 10, 11, 12. Are they equivalent? Yes, they are equivalent because n of A equals n of B equals 3. Are A and B equal? Yes, because even they have repeated elements, and but they have the same elements here, which is 10, 11, 12. They matches. So yes. Okay, this is the lecture about chapter 2.1. If you have any question, please email me or let me know in the tutoring session. Have a good day. Bye.